All right, example 1, the train made the trip in 3 hours, the girls walked it in 15 hours. It says made the trip and walked it, implying the same trip, so that tells me the distances are equal. So I know that the train went some unknown distance, the girls went the same distance. I'll make girls and trains my category. So the distances are equal to each other, train distance equals girls distance. So that's the first thing I always do in these problems. Once I've established the distance relationship being equal to each other, I'll make that D prettier. Then I make my chart. So I got train and girls. And I need to identify things about rate and time that they tell me in the problem. So I'm focusing on these 4 boxes here. How fast did the train go? How fast did the girls go? How long did the train go? How long did the girls go? So the train made the trip in 3 hours. That's the time. So train time is 3 hours. Girls walked it in 15 hours. That's the time. Girls have 15 hours for a time. The speed of the train was 32 miles per hour faster than the girls walked. So the train's going some speed. The girls are going some speed. Let's make the girls go R miles per hour. The train's 32 miles per hour faster than that. So whatever the girls walk plus 32 is the speed of the train. And now once I get rates and times, if I multiply rate times time, I get distance expressions. Distributive property where necessary. Binomial times monomial, distributive property necessary. So 3 times R is 3R. 3 times 32 is 96. R times 15 is 15R. That's just one thing times one thing, so just do a straight multiplication. Distance of the train, which is this expression, equals distance of girls, which is this expression. So we set that equation up. 3R plus 96 should equal 15R. Move the 3R over. That gets me 96 equals 12R. We divide by 12, we get R equals 8. Now, once I've gotten an answer, in this case R equals 8, I have to use the chart up here, find that letter to figure out what that thing represents. So R represents the rate or speed of the girls. If they said, how fast do the girls walk, I'm done. But the question specifically asked me here, how far was it? How far is distance? So we know the distances are equal to each other, so I can either put R right here or right here to figure out the distance. I'm going to go on this bottom one. 15 times 8, 120 miles is the distance. If I'd gone the other one, 3 times 8 plus 96, 3 times 8 is 24, 24 plus 96 is 120. Get the same answer regardless, but that was a lot quicker. Number 2, gold was worth 451 marks a gram. A mark is an old German currency, and a gram is a unit of mass. And copper is worth 7 marks a gram. So they're talking about value in marks and mass in grams. So if we deal with this in that manner, we have mass of coins, we have value of coins. Mass is in grams and value is in marks. And we have gold and copper as our categories. Okay. The grams of gold we'll say is G. So G grams of gold and C grams of copper. And as far as value is concerned, every gram of gold is worth 451 marks. We have G grams of gold, so 451 G is the value of the gold in marks. And every copper is worth 7 marks a gram. We have C grams of copper, so 7 times C is the value of the copper in marks. And now we just look for facts. So fact number 1, 11 gram mixture of gold and copper. So the grams of gold plus the grams of copper equals the grams of metal. Worth 1,853 marks. The value of the gold plus the value of the copper is equal to the value of the mixture. That's marks, and everything else is marks, so we don't have to convert anything there. And now my system of equations that I get, I'm looking at it to see elimination or substitution. Elimination looks a lot easier. Times -7 on top will make -7c, that'll cancel the c's. So -7 times g is -7g. -7 times c is -7c. -7 times 11 equals -77. 451 minus 7 is 444 g. 7 c's cancel. 1853 minus 77 is 1776. Divide both sides by 444, we get G is equal to 4. And G represents the mass of the gold in grams. The question asks us specifically, how many grams of gold did he have? So that's exactly what we found, so 4 grams. If they ask for how much copper did he have, 4 plus 7 makes 11, so 7 grams of copper, we could easily find that. But again, all they asked us for was gold, so just give me that answer. Number 3, 25% of the people did not like the king. So 25% of the people. So percent of means part whole. The part is the 25%. The whole is all the people. And the characteristic of the 25% is the people who did not like the king. So actually, those people who did not like the king were the part. So whenever it says of some category, some group, so 25% of this group, the group is the whole, and the characteristic of the group is the part. So we have did not like the king, and the whole is all the people. If we look at the percent, and then actual, okay, we know 25% of the people did not like the king. So 25% did not like the king. All the people is 100% of the people. So anytime you do a part whole, the whole gets 100%. Now, if we take a look at the next statement, it says 12,500 people did not like the king. If this matches this, you get to put it here. If it says 12,500 people were in the kingdom, that would go down here. So again, pay close attention to what they're giving us. 12,150 people did not like the king. So 12,150 goes there. Unknown is what we're looking for, because how many people lived in the kingdom is the question. That's what we don't know. That gets me 25 over 100 equals 12,150 over x. We can see that 25/100 reduces to 1/4. I recommend reducing if possible. It makes it easier. So if I cross multiply now, this product 1x is equal to this product 4 times 12,150 is 48,600. Okay, number 4. Debbie has a bag that contains 14 green marbles and 4 gray marbles. So there's her bag, 14 green and 4 gray. Okay. We want the probability that she draws 3 marbles. So she's trying to draw 3 marbles, and very important, without replacement. Okay, without replacement means when she reaches in to grab a marble out, she pulls it out, it's going to be the color she was looking for, and she doesn't put it back in. That's going to change how many marbles are in the bag for each different pick. And our goal here is to get probability of green on the first pick, green on the second pick, and green on the third pick. Okay. So the initial pick, what we have in the bag is 14 green, 4 gray marbles. So the chances of getting a green on the very first pick, 14 green out of 18 marbles. Once she picks it, she pulls it out, it's going to be a green marble, we set it aside. We always get what we're looking for. So that means after she picked that marble, one of the green marbles went away. There's still 4 gray, but now there's only 13 green marbles. So the second pick, now she reaches back in this bag having 17 marbles in it, only 13 of which match the criteria of what she's looking for. And she reaches in, pulls it out, has a green marble, sets it aside. Now she's only got 12 green marbles and still 4 gray. So the final pick, she's trying to pick a green marble. Now there's 12 plus 4, only 16 marbles in the bag, of which 12 are green. So the chance of getting a green on the third pick is 12 out of 16. The final step here is to multiply all this stuff together, but reduce first if possible. 14 and 18 reduced by 2 down to 7 and 9. 9 and 12 reduced down to 3 and 4. 4 and 16 reduced down to 1 and 4. 13 and 17 are prime, they don't reduce with anything, so that's as much as I can possibly do. So I'm left with 7 over 3 times 13 over 17 times 1 over 4. 7 times 13 is 91 times 1 is 91. 3 times 17 is 51 times 4 is 204. So 91 204 would be the probability of picking 3 greens without replacement. Number 5, it says find n. Our first priority on an abstract equation, bunch of variables with fractions, is to get rid of the fractions. So I don't even care about this until I get rid of fractions. So the only fractions are f over n and 3r over m. The least common denominator is nm. I'm going to multiply everything by nm, reducing first, then multiplying result. So nm divided by n is m, times f is fm. Nm times minus j, there are no fractions, nothing cancels, so I just simply get minus jmn. When I do nm times 3r over m, m divides by n to make nothing, n's left over, n times 3r is going to be plus 3nr. And finally, when I do nm times z, just like the j, there's no fraction, nothing cancels, so I'm going to get mnz. I put everything in alphabetical order. It's not required. I like to do it that way, just a better way of organization for myself. Once you've done that one step, got rid of all the fractions, now you want to focus on this direction, find n. Anything containing n is more important than everything else. So this has no n in it. This has an n, this has an n, this has an n. So those three things underlined in black have to be on the same side. Two ways of making that happen. I can move fm to the right, mnn to the left, mnz to the left. Or what I'm going to do is move jmn and 3nr over to the right. So the red and the green objects are going to move to the right. The blue and the purple objects are going to stay right where they're at. So fm staying on the left-hand side stays positive. mnz stays on the right-hand side, stays positive. jmn moves across, the equal sign becomes negative. 3nr moves across, becomes negative. So now we have everything containing n on the right-hand side, everything not containing n on the left-hand side. So my next task is whatever this letter is, I want to take it out of this expression on the right-hand side. So don't even worry about this side over here. This side is just going to move along, become the same thing. But I want to see that there's an n here, there's an n here, and there's an n here. Common factor of n allows me to pull an n out. mz plus jm minus 3r is left over when I take an n out of each term. And then, once I get to this point, whatever's on this side all by itself is the top part of my fraction answer. Whatever is multiplied by what I'm looking for is the bottom of the fraction answer I'm looking for. So, my final answer is going to be n equals, what I'm looking for, n equals. And then I just put the top, which is fm, over the bottom, which is mz plus jm minus 3r. Okay. The n stays on the side by itself. This divided by all this is the answer, and that's what it should look like. Number 6, an abstract, no, not even an abstract equation, a rational equation with a single variable m. So this has a whole bunch of different variables. This is how you want to go ahead and do it. When you only have a single variable in a problem like this, you're trying to find a numerical answer. But when you're dividing by a letter, you have to account for the possibility that division by 0 might occur. So you cannot divide by 0, so we have to investigate this denominator, every denominator, and ask myself, what makes the denominator equal 0? So in this case, it's just 0. If it was like m minus 3, then 3 would make it equal 0. So it's not always going to be 0, but 0 makes 0, 0 makes 0, 2 divided by 0 is no good. So m equals 0 is illegal, so we make just a note of that, put that on the back burner. It's important, but not quite yet, but it's good to do it right off the bat. Next step. Once you've established that m is not allowed to equal 0, now we can legally get rid of the denominators in this problem. I'm going to multiply everything times the least common denominator of m. So just like before, m times this. M cancels m, leaving me with 1 times 3 plus m. This times this. M cancels m, leaving me with negative 2 times 1. And m times this, m times 0 is just 0. Right? Once you get all this quotients times the tops, if you have a situation with a binomial, make sure you distribute every time. Make sure that you think about that idea. So 1 times 3 is 3, 1 times m is m. Minus 2 times 1 is minus 2 equals 0 is equals 0. Once I get the fractions out of the problem, now I simply have a real easy algebra problem. M is m, 3 minus 2 is going to be plus 1 equals 0. Move the 1 to the other side and simplify. M equals negative 1. At this point, my investigation says m is not allowed to equal 0. I got m not equal to 0, it's equal to -1, so that's the fine answer. Going through all this work, and at this end point I got m equals 0, I'd have to throw that answer out. It's unlikely it'll happen, but that's just something to think about. Number 7, same type of problem, except this time 3, 5, and 15 in the denominator. There's no variables in the bottom, so we don't have to worry about that whole what makes the bottom equal to 0 question. All we have to do is multiply by least common denominator of 15. So 15 divided by 3 is 5 times the top. 15 divided by 5 is 3, and notice it's minus, so minus 3 times the top. And 15 divided by 15 is 1 times the top is equals 8. So divide by the denominator, multiply result times the numerator. 5 times x, 3 times 2 plus x, 1 times 8. And next, again, simplifying is very important that we do it correctly. What I want to focus on is this minus 3 that happened here. So the minus sign's there. 15 divided by 5 made the 3. We're just multiplying -3 times the top. Very important that we get -6 minus 3x. This is a very easily forgotten negative sign. If you were to just do this mentally, 15 divided by 5 is 3. 2 plus x is 6 plus 3x. And then forget the minus sign distributes through. So be careful that you actually write it like this and you get all that happening properly. 5x can't be any simpler than it is, and equals 8 can't be any simpler than it is. So that's priority, we'll call that priority 1, 2. Get rid of the fractions, simplify as much as possible. Once you get to this point, now it's just a matter of solving the equation. X number, I'm going to put the number over with this, so plus 6, minus 6 moves over as plus. 5x minus 3x on the left-hand side is 2x, 8 plus 6 is 14. Divide both sides by 2, that gives me x equals 7. So it's a pretty simple problem once you fix it, but fixing it does, again, a lot of people miss that sign there. Be careful that binomial with a minus in front of it, that it distributes through. Number 8. The two scenarios for absolute value inequalities. Scenario 1 is absolute value of x is less than a positive number. That creates a compound, or a conjunction. The negative version of that number, so it's less than 6, negative 6. Less than 10, negative 10. Less than 1, negative 1. All right? The negative version of the number, less than x, less than the positive version, so it's 10, 10, 5, 5, whatever. The other possibility that really matters is absolute value of x greater than a positive number. And what that creates is a disjunction, x greater than the positive, or x less than the negative. Again, if it's positive 6, negative 6. Positive 10, negative 10. So whatever number it is, that's what goes there. So I can't do this problem like that until I get it to look like one of these two pictures, which it doesn't currently look like. It doesn't say absolute value of x all by itself, and then an inequality symbol followed by a number. So a couple things have to happen. Number 1, all the numbers have to be over there. So move the 4 over, minus 4. Negative absolute value of x is left on the left, less than negative 1 on the right. Moving things across the inequality symbol has no effect on the inequality. Whatever it is, it stays that. Still, it's closer to what it's supposed to look like, except now it's negative absolute value. Both these say positive absolute value. So I need this negative to go away, so I need to make this positive absolute value of x. Change this sign requires me to change that sign, and changing both signs requires that I flip the inequality around. So it ends up having this picture here. And just for the sake of having some different colors here, let's go with red there and green there. So, absolute value of x greater than 1 means that either x is greater than 1 or x is less than negative 1. So again, it's always x without the absolute value bars. Exactly what you're seeing without the bars, and then without the bars, flip it, change it. Okay, and then all I have to do to graph this is just fill out my number line with numbers. And just graph both of them on the same number line. X is greater than 1 is an open circle at 1, not equal to, so we're doing the open circle to say this is where I'm starting, but I don't include 1. And then I shade to the right, because to the right is greater. X is less than negative 1, open circle at negative 1, because again it does not say equals, so we do want to include negative 1, but we want to start there. Less than goes to the left, so I'm going to shade to the left, shade the arrow, and there is our entire answer. And that's what I'm grading on this problem is the actual graph there, so make sure you do graph it correctly. Number 9, round the square root of 57 to the nearest millionth. So if I type in square root 57 equals, if My calculator spits out a number. I'm going to write down every decimal place that it shows me. So 7.549834435. Be very careful that you don't forget one of those digits. So 5498, whatever. So make sure you write down every digit you see. Then we want to find the nearest million. Okay, so if we count place value, we have tenths, hundredths, thousandths, 10,000, 100,000, millions. So the millionths place is right here. And the next digit after the millionths place is a 4, which is not 5 or bigger, so we just chop that off. 7.549834 is the correct answer. I'm not necessarily going to ask for the millionths on the test. It could be thousandths or 10 millionths, whatever. But your calculator should give you a number big enough that you should be able to round it. 5 through 9, make this one bigger. 4 through 0, keep that the same. Chop everything else off. Number 10, find K. We'll see here there's no right angle marked. If I forgot to do that on the test too, just whatever looks like a right angle on that problem, pretend it's a right angle for the sake of this test. When you look at a right triangle, the two sides that make the right angle are the legs. So this is a leg, and this is a leg. And the side across the triangle from the right angle is the hypotenuse. And the Pythagorean theorem tells me that leg 1 squared plus leg 2 squared equals hypotenuse squared. That's the Pythagorean theorem, exactly as it's supposed to be written. Don't always just square things and add. Just write out the theorem and then do what you have to do algebraically to get the right answer. So k squared is fine for right now. 6 squared is 36. 8 squared is 64. Move the 36 over. Becomes negative 36. So k squared is equal to positive 28. That means k is going to equal the positive or negative square root of 28. If I punch in my calculator square root of 28, it gives me 5.29 and so on. I'm going to go with k equals 5.29. Notice, officially, k squared equals number, k equals plus or minus square root. But since we're trying to find the leg of a triangle, legs are positive, so we take the positive square root only as our final answer. And again, square root of 28, use a calculator to approximate a couple decimal places will be fine. If you do want to leave it in radical form, square root of 28, do simplify. 28 is 2 times 2 times 7, pair of 2's gets pulled 2 out, so 2 times the square root of 7 will be the exact answer. If you want to leave it in radical form, I expect it to be simplified as much as possible. If you want to use a calculator, just use a calculator. So I recommend a calculator just to avoid any kind of discrepancies here. Number 11, there's no graph paper on your study guide, but there will be on the test, so I just went ahead and drew some graph paper here. So, if we take a look at the point 3, 4, origin 0, 0, 1, 2, 3, 1, 2, 3, 4, it'll be right there. And if we go from the origin, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 will be right there. And I draw a line through those 2 points, like so. Okay, slope is defined as rise over run. So if I want to go from the red dot to the blue dot, I want to first of all go the rise, which is the vertical change to get to the right height, and then the run, which is the horizontal change to get to the right spot. Okay, so if I'm looking at these 2 things, I'm going 1, 2, 3, 4, 5, 6, 7 spaces down. Down is a negative direction, so it's negative 7. I'm going 1, 2, 3, 4, 5 spaces right. Going right is a positive direction. So looking at rise and run, I'm going from here to here, then to here. So down, then right. Don't go like this and like that. I've seen people go down and left to get to this spot here. I want to go from red, down over to get to blue. So make sure you go in each direction correctly. Rise over run is slope. So the slope in this case is simply negative 7/5. Whatever the rise is over whatever the run is. Number 12. We have a quadratic equation. We want x squared positive. Right now x squared is negative, so I'm going to move everything that isn't 0 over to the right. So x squared is going to stay, I'll move to the right, it's going to become positive. 15x is moving left, becomes positive. 50 is already on the left, so it stays positive. And now everything's off the right, so it equals 0. So that's priority 1, get the quadratic expression equal to 0. Once you get the quadratic expression equal to 0, we'll try and find the correct breakdown here. 5 times 10, that 5 plus 10 makes 15. 2 times 25, 2 plus 25 is 27, no good. So there's only one breakdown here for a product and a sum of the same two numbers to make those two numbers in the problem. Once you find that correct breakdown, that gets me factored form. And once I get factored form equals 0, either factor 1 equals 0 or factor 2 equals 0. I simply need to solve each of those individually. So if I move the 5 over here, minus 5, that gets me x equals negative 5. Move the 10 over, minus 10. 0 minus 10 is negative 10. So my solutions are negative 5 and negative 10. Set each factor equal to 0, solve simple algebra problems at that point. Number 13, evaluate. This is called the quadratic formula. It's something we're going to be investigating lesson 119 to actually use it. But for now, we want to learn how to evaluate it. So we get to that lesson, we'll be able to do it pretty easily. The quadratic formula has this structure every single time. Some number plus or minus some square root over some number. And the three pieces of the quadratic formula are minus b, which goes right here, 2a, which goes on the bottom, and b squared minus 4ac, which goes underneath the radical. And of those three things, the only even slightly challenging thing is the b squared minus 4ac, so we'll do that last. So if I start off with minus b, so I know that b is equal to positive 15, minus b means change the sign, so minus 15. If b was negative 7, minus b would be positive 7. So whatever this is, opposite sign goes there. Moving on to 2a on the bottom. A is equal to positive 1, 2a is 2 times 1. So whatever a is, you double it, that's what goes on the bottom. So again, very simple. You change a sign, you double a number. The last object is b squared minus 4ac. B squared means to square b. 15 times 15 is 225. Minus 4ac means to subtract the product of 4 times a times c. A is equal to 1, c is equal to 50. So this product is subtracted. 4 times 50 is 200. 225 minus 200 is 25. That's what goes right there. So that's how you fill in the three spots of the quadratic formula. Now, what's going to happen on the test, what happened here even, is that this is an exact perfect square. The square root of 25 equals 5. It will evaluate like that on the test too, so make sure that you're expecting that to happen. If you stop here, I'm going to give you half credit for being right, but not full credit for getting the best answer. All right, square root of 25 is 5. Negative 15 plus or minus 5 over 2 is what we end up with. That gets me two solutions. First solution is something over 2. The second solution is something over 2. It's this whole sum and difference over 2, so they're both going to be over 2. Plus or minus means to add and subtract. So negative 15 plus 5 is negative 10. Negative 15 minus 5 is negative 20. Negative 10 halves is negative 5. Negative 20 halves is negative 10. So if you get all the way down to this, you'll get full credit. Again, if you stop here with the square root of 25, you'll be right, but you won't be fully right. So I'm expecting these final answers looking like this. Number 14, find the area of the shaded portion of the parallelogram. So we have the parallelogram. Area of a parallelogram is base times perpendicular height. 15 times 16 is equal to 240. We have a circle. The area of a full circle is pi times the radius squared. 3 squared is 9. 9 times 3.14 is 28.26. And it's parallelogram minus circle because circle's cut out. So 240 minus 28.26 is 211.74 inches squared. And finally, number 15. Lateral surface area of the right prism whose bases are regular hexagons. First of all, let's focus on the bases. Regular hexagons. Hexagons means 6 sides. Regular means all sides equal. So vocabulary is important here that you know what these words mean. So this side's 10, which means all the sides are 10. So I got 1, 2, 3, 4, 5, 6 sides, 10 each, which is a perimeter of 60. I can see the height of this is 14. Now the one thing I can't figure out what the area of the base is. So now I'm maybe racking my brain. Well, I know the surface area formula says surface area is equal to 2b plus pH. But if I look more carefully at the question, it says to find the lateral surface area. Lateral surface area is the area of everything but the bases. 2b is the area of the bases. So if I want to find lateral surface area, I simply cross off the 2b. It's just p times h. We know what p and h are, so the lateral surface area in this case is simply going to be 60 times 14, which is 840 units feet, so feet squared. And it will be lateral surface area on the test, so you should expect to be able to handle that when it comes time to do it.